Hello friends, I Pankaj Dumka welcomes you all to this session on thermodynamics. But today I will not be speaking on any specific topic. Rather, I will be answering a question which one of my YouTube viewer has asked me. So the question is very simple. What he said, if you have a spontaneous process, and that means an irreversible process which is happening due to finite gradient, then for that process, when entropy and volume are kept constant, then why entropy changes less than zero? Or for this process to be spontaneous when entropy and volume are kept constant, so why internal energy change will be less than zero? So to understand that, I have to give you one more answer that which you have said wrongly. You said that du is equal to TdS minus PdV is valid for irreversible process. But friend, remember that in this particular equation, du is equal to TdS minus PdV. This is how I used to write volume, please pardon me. So in this process, in this equation, each and every variable, whether it is a pressure, volume, entropy, temperature, internal energy, they all are point functions. And when in an equation every variable is a point function, then this particular equation is valid for both irreversible and reversible processes. It is immaterial whether you are talking of a reversible process or irreversible process, because if you have, let us say this is a pressure volume plot, and you have two state points 1 and 2. So this is, let us say, a reversible path, and this is an irreversible path. But as you are only talking of the state variables, that means the variables or the quantities which only depends on the endpoints. That is, they do not depend on path. They are perfect differentials. So it is immaterial whether you are moving from here or here. Therefore, this particular equation is valid for both irreversible as well as reversible process for a closed system. Okay. Now come to your problem. So to understand why entropy, when entropy and volume are kept constant for an isolated system, and for a spontaneous change in process, why internal energy change is coming out to be less than zero. So to understand that, consider a reservoir, a thermal energy reservoir at temperature T. So this is a thermal energy reservoir. Now what is a thermal energy reservoir? A thermal energy reservoir is that which is having an infinite heat capacity. So whatsoever you take from it, whatsoever you give to it, there will not be any change in the temperature of that particular reservoir. And you have a system, a closed system. Now, let's say that in universe you have only these two, a reservoir and a system. System is at lower temperature, reservoir is at higher temperature. So due to that, there is a heat transfer taking place from the reservoir to the system. And due to this temperature gradient, this heat transfer is a spontaneous, that is irreversible process right now. So in this, the entropy change of a whole universe will be what? The entropy change of reservoir, that is the entropy change of reservoir, plus the entropy change of system. Let us say ds is the entropy change of the system. And that has to be more than zero, because the principle of increase of entropy says that the entropy of the universe will always increase. It will never reduce. Okay. Now, what is the entropy change of the reservoir? It is, as it is losing energy in the form of heat, so it is minus dq by t, because that is happening at a constant temperature T. So plus ds is more than zero. You multiply the whole equation by temperature. This becomes TdS more than 0. Now you multiply this equation by minus 1. So what will happen? The inequality changes. Yes. So this is dq minus TdS. Now it becomes less than 0. Now for a closed system, how you write the first law of thermodynamics? For a closed system, you always write dq is equal to du plus pdv. Okay. Now you replace the value here. then this du plus pdv minus tds will be less than 0. Now comes your question. What will happen for this spontaneous process if entropy is a constant and volume is also a constant? So friend, if entropy is a constant, so the change in entropy will be 0. That is isentropic process. And at the same time, if volume is also kept as a constant, then the change in volume will also be 0. That is isochoric. So if you look the equation, so entropy change not allowed, volume change not allowed. So what happens? That internal energy change should be less than 0. So if there is a spontaneous process and the process is such that the entropy is also not changing, okay, and the volume is also not changing, then for that spontaneous process the internal energy should always reduce. Okay, and remember one very important thing, that entropy is a critical parameter to determine the state of thermodynamic equilibrium of an isolated system. The entropy of an isolated system always increases and reaches a maximum value when equilibrium is reached. So with these words, I close the video, and if again you have any problem to ask, then please do write in the comments. I will be answering that as well. Thank you very much for showing interest, and in fact for feeling that I am capable enough to answer your question. But still, if I haven't answered it well, then please do write. I will again try to answer your question in some different way. Thank you very much for watching it. Take care.